Hello everyone, my name is Alshar Famil, and in this video I will explain what I have done for COMP3123 Assignment 1. The main goal of this assignment was to work with the fashion MNIST dataset, explore and visualize the data, build a neural network using keras, train the model using different configurations, and evaluate its performance. So first, I started by importing the required libraries such as NumPy, Matplotlib, and Fashion MNIST dataset from Keras. After loading the dataset, I examined the dimensions of the training and testing dataset. The training dataset contains 60,000 images, and the testing dataset contains 10,000 images. Each image is 28 by 28 pixel and is in grayscale. I also verified lengths i- of the training and testing levels to ensure they matched the number of images. Next, I printed some of the tra training and testing level and examined the digital pixel values of selected images from both dataset. I visualized specific images for from the timing and testing sets using Matplotlib to better understand the structure of the data. Each image belongs to one of 10 fashion categories, and such as t-shirt, trousers, dress, sneakers, and ankle boot. I confirmed the class levels by mapping the numeric level to their corresponding clothing categories. Then before building the neural network, I proceed the data. First, I reshape each image from 28 by 28 pixel into a one-dimensional vector of 784, which is required for a fully connected neural network. Then I normalized the pixel values by dividing them by 255. Then I normalized the pixel. This step scales the values between 0 and 1, which helps improve training stability and performance. I created sequential neural network model using Keras. The model includes two hidden layers. The first hidden layer contains 512 neurons, which with the ReLU activation function, and the second hidden layer contains 128 neurons, also using ReLU. The output layer contains 10 neurons with a softmax activation function. Softmax is used in the final layer because it converts the model output into probabilities for each class, and the class with the highest probability becomes the predicted level. And in question 7, I used the Adam optimizer with the sparse categorical correspondentropy loss function, which works with integer level. In option B, I used the RMS prop optimizer with the categorical cross tropy loss function, which required converting the level into one hot encoded format. For both configurations, I trained the model for 10 epochs using the fit function and observed the training accuracy. And for question 19, um, fashion MNIST is more challenging than the original MNIST dataset that we learned in class. MNIST contains handwritten digits, which has simple and clear distinguishable shapes. In contrast, fashion MNIST contains clothing items that often look very similar to each other, such as shirts and t-shirts or sneakers and ankle boots. Because of this increased visual similarity and complexity, fashion MNIST usually result in lower accuracy compared to MNIST when using the same type of neural network. For question 20, the difference in accuracy can be explained by several factors. First, clothing images have more complex texture and patterns than handwritten digits. Second, many of the fashion clothes overlap visually, which increases misclassification. Third, the model used in this assignment is fully connected neural network and does not include conventional layer, which are more effective for image recognition tasks. And finally, for question 21, I used evaluate function in Keras to calculate the loss and accuracy on the test dataset by comparing the training accuracy With testing accuracy, I checked for overfitting. In this case, the training accuracy is slightly higher than the test accuracy, which is expected. Since the difference between them is not large, the model does not show significant overfitting and generalizes reasonably well to unseen data. In conclusion, this assignment helped me understand how to load and explore datasets, pre-process image data, design and train neural networks, and evaluate model performance using keras. Fashion MNIST provides a more realistic and challenging dataset compared to MNIST, and this assignment strengthened my understanding and deep learning fundamentals. Thank you for watching. That's all.